Okay, in our previous segments, we talked about how to derive the ideal gas law, PV equals NKT. And I said that one way of doing it was the concept of work. And we said that the work done on a gas is pressure times volume. And then we related that to the heat inside the gas, which was NKT. And then we put the two of them together and we got the ideal gas law. So that was a macroscopic way of deriving the ideal gas law. Could we do it using microscopic principles? And remember, microscopic description of gases is called kinetic theory. And yes, we can. So let's see if you can understand this. So number one, the energy of a gas is going to be proportional to its temperature. So we found that out, that the kinetic energy of a gas is equal to 3/2 kT. So that was the translational kinetic energy. So if we increase the temperature, we're going to increase the kinetic energy of the molecules. Does that make sense? So they're going to be moving with more kinetic energy. Okay, now the next thing I did is I wrote down the kinetic energy. So kinetic energy is 1/2 mv squared. Okay, but I want to write that in terms of momentum. So momentum was given by a lowercase p, and so this is from a previous lesson, and momentum was equal to mv. So what I'm going to do is take this equation, solve it for the letter m, which would be p divided by v, and then plug that up there. And so I end up with that the kinetic energy of these molecules, the average kinetic energy of these molecules, is going to be 1/2m and then p squared. So why is that important? So as the kinetic energy goes up, the momentum goes up, which means that they're moving faster. So as we increase the temperature, the molecules are going to start to move faster in the gas. Okay, let's keep going here. Now we have to remember what was the definition of the second law, Newton's second law. So normally Newton's second law is written force equals ma. But we can also, so go back to a previous lesson when I talked about this, we could write Newton's second law in terms of momentum. And it was going to be the change in momentum with respect to time. So a force changes the momentum of a system. If you don't believe me, go back to one of my previous lessons when I talked about momentum. And it turned out that force changes the momentum of a system. So as we increase the momentum, so notice this is a chain reaction, so we started off with increasing the temperature. When we increased the temperature, it gave the molecules more energy. The more energy they had, the more momentum they have. Okay, now we're going to say the more momentum they have, the more force they have. So when they hit the sides of a balloon, they're going to be hitting with more force. And then finally, what's the relationship between force and pressure? So pressure is equal to force divided by area. And so as we increase the force, it increases the pressure of the gas. But that's this formula up here. So we started off by saying, let's increase the temperature. So as the temperature goes up, the pressure goes up. And so we can actually derive this formula, PV equals NKT, by using the principles of kinetic theory. Okay, let's take a break. When we come back again, let's talk about the mean molecular speeds of molecules.